Hello and welcome to week 9 of programming with C Sharp. I'm Jim Kaufman with Rankin Technical College. So this week we'll be covering chapters 14 and 15, and I have a kind of a quick guide for each one of those chapters. Now, today, so we're going to try to cover both guide 14 and 15 today. And then tomorrow I will go through some demos because the lab assignments will be over both chapters 14 and 15 this week. So I'll try to get through both 14 and 15 today, lecturing. And then, like I said, tomorrow we'll go ahead and look at the demos that are, somewhat similar to the lab assignment. So I know that we've talked about some of these concepts already regarding inheritance and base classes and that. So you kind of have a little bit of an introduction already, but I'm going to spend some time kind of digging a little deeper into this. And, maybe if nothing else, some areas will be a little bit of a review, which is really important anyway because classes and, object-oriented programming and all these different things are a little more advanced, and it's really important to get a good handle on them going before kind of going forward with the class and the programming language, right? Okay, so regarding .NET inheritance hierarchy, so in C Sharp, every class is ultimately inherits from the system object. So this means every object, whether it's a string, a button, or a class that you write yourself, automatically has access to the methods defined in object. Okay? And actually, let me just, for the heck of it here, let me pull up. So if we come down here and I'm just going to do this on this toString because this is one of the methods. We've got this animal object. We're going to come back to this animal class and the dog, right? Dog is basically the derived class. Animal is the base class, which we'll talk about here in a minute. But here's a toString method, and this is one of the methods that actually inherits from the object. So if I actually click in here and then go to base, right? This is the base implementation of the toString method, right? And this is basically it's system object, right? This is the system object class, which everything pretty much inherits from, right? And so that toString method is a basic base method that can be inherited in, and you can actually, and we'll look at it here a little bit more, and you can actually override it as well, okay? And so we're moving on to that. So here is some of the methods, like I just mentioned, toString. So this returns a string representation of the object, okay? And you can overwrite this to customize it, okay? The equals method. So the equal message, well, you can use this to determine whether two objects are equal to each other. So as we kind of talked before, we've created our own objects, right, already? And if you create two objects of the same class, and even if you assign them all the same data and everything, they are still two independent objects, right? They have their own memory location, and they're basically, they're their own unique objects, right? So when you let's just say you try to do equals on two objects you just created with all the same data, right? And actually by default, they're not equal to each other, right? They're because basically by default, it's going to do it's going to actually use what's going to compare them by reference, okay? Basically by memory reference, right? Where they are in memory, right? And so by default, even like I said, you have two objects that have all the same data. They're not going to be equal to each other. Now, you can actually override the equals method, okay, in your objects so that you can compare them based on the data, right? So there is still a way to compare two objects that are all unique, like I said, from a reference memory location perspective. But if they have the same data, we can overwrite the equals method to check all the data in your objects. And that if they match, then we can actually say, yes, they are equals. Okay. And then there's also this get hash code. And get hash code, it returns a specific code for the object. Okay. And it's used in collections like dictionaries, and we'll learn more about that in the future. But it basically helps with ordering things and making things a lot more efficient and quicker when you get, a lot of times, a lot of things we do on computer, especially when we have simple little demonstrations and we're doing things, it's very quick, it doesn't matter. But when you're working on a substantial application that may have thousands or millions of rows of data that it's processing or using, right, then it becomes very important for that to be very efficient, right? So Git hash code can help with that efficiency, all right, and we'll learn more about that in the future. Get type is it returns a type object that contains information about the object's type. Okay. So why does this matter? So you can call toString or get type on any object because those methods come from the object. Okay, from that system object. So the ultimate ancestor, and so that the object is the ultimate ancestor of every class. So here's a window forms hierarchy example. So the .NET framework itself is built using inheritance. So for example, the system Windows Forms namespace, there's a control, right? And then, so there's a control class that provides properties and methods that all controls have in common, right? So like text, visible, enabled, all of these are common to button and text box and label, right? So basically, button inherits from control, control inherits from the system object, okay? So it's just saying this is why you can set the text on a button, a text box, or a label. They all inherit that property from the same control base class, right? Inheritance basics. Inheritance lets you create new class, the derived class or child class, based on an existing class, the base class or parent class, right? It's called the same thing, it's just kind of just a different term. Kind of I don't want to say old school, but we used to not really call them derived classes or base class. We used to call it child and parent, right? You had your child class and you had your parent class, right? Um, Within time, they've kind of changed that a little bit, but it means the same thing. A child class is a derived class, and a base class could be also called a parent class. So the derived class inherits all public and protected, and it's very important, right? All public and protected members from the base class, and can add its own, right? So you can derive something and then add your own methods to your derived class, right? So you get all the good stuff from the parent class, then you can go ahead and add your own that can be used by your derived class. So key facts about inheritance. A class can be both a base class and a derived class at the same time. Okay, and so down here it's kind of showing an example. So we'll get there here. So a class can be both a base class and a derived class at the same time. For example, motor vehicle can inherit from vehicle, while also being a base class of automobile and motorcycle, right? So motor vehicle is automobile and motorcycles base class, right? but it itself is a derived class of vehicle, right? Automobile is a derived class of motor vehicle, and motor vehicle is a derived class of vehicle, right? So everything in vehicle is available. If well, I shouldn't say everything. Everything, like I just said up here, everything that is inherits all public and protected members. Okay, so all public and protected members, right, that are in motor vehicle, are that are in vehicle, right, are also also in motor vehicle, right, are available in motor vehicle, right, and then everything, all public and protected items in vehicle and motor vehicle are available in automobile, right, and motorcycle as well, right. And then so it's a little different over here. This arrow's kind of not really in the right place, but here's a different one where watercraft, right, inherits from vehicle, right. So watercraft is the derived class of the base class vehicle, right. Whereas sailboat is the derived class of the base class watercraft. Okay. Access modifiers in inheritance. So access modifiers control who can see and use a member, who can see and use a member. So in inheritance context, the protected keyword becomes especially important. Okay, so public is basically anywhere. We've talked about this before. Anywhere, the class itself, derived classes, external code, almost anything. If it's public, it's pretty much accessible. Public means public, right? Protected, on the other hand, so it's available to the class itself where it's defined, right? And any class that inherits from it, right? Any derived class, okay? But not from external code, okay? Not from external code. So you can't create one class and then create another class. And if that second class didn't derive from that first class, right, then it cannot have access to the protected stuff. And then private is only in the class itself, right? Not derived classes, not external code. So let's look at this here. So here you've got an animal, all right, some different properties. You have a name, you have a heart rate, you have a DNA sequence, right? Then dog, right? Dog is inheriting, right, from the base class animal, right? And then here it's got a method called show vitals where it's name equals Rex. So name, since it's public, it has access to that, right, in the derived class, right? Well, it would have access to anything, right? Since it's public, it wouldn't necessarily even need to be a derived class. Even if this here did not exist, since it's public up here, it would still have access, right? Public, it works. Here is protected, right? Heart rate. It's protected, and since this dog is a derived class, it has access to that, so that you're good there, right? Whereas private, nope, private is only available within the class itself, where it's defined. Okay, so you cannot access private members of a base class from a derived class. This is very common mistake. If a base class has a private method, the derived class cannot call it, even though it inherits from the class. When to use protected? So use it for members that derived classes need access directly, right? If if this is something that a derived class might need, then you make it protected. Otherwise, it needs to be private, right? It's kind of a situation of least access, right? The idea is you never really want to give someone access. You never want to give someone or In our case, when I'm saying someone, like access to systems, when people grant permissions for somebody to access something, individual, right? There's this idea of least privilege, right? So you don't give someone access unless they really need it, right? Unless they really need it. And the same thing holds true for programming, in programming for classes and so forth. If you know that a derived class is not going to need something, you don't make it available, right? Make it private. So by default, you probably should make things private unless you know, oh yeah, this derived class is gonna need it, so I need to make it protected, right? And then your next question, I guess, needs to be is this something that I want to allow access from pretty much anywhere, right? We'll kind of look at that. A lot of stuff we've been doing, we do things, especially with WinForms and everything's kind of wired, everything's kind of part of the same namespace and stuff, right? So it's kind of a little bit different, but we can still we can still create some examples to demonstrate, that this is a public class, right? And so this can have access to some other, to other public members of other classes, right? So, but you always have to think is it really important for some member to be something in your class to be public or not, right? And the idea of least privileges, it's important for you to know that, and it's very important in programming and access control. Always it's kind of a well-known, used concept, right, of least privilege. That you never give anything access more access than it needs, right? It's always easy just give them access to everything, right? Constructors and the base keyword. So when you create a derived class object, the base class constructor runs first, then the derived class constructor runs. If the base class has a parameterized constructor, the derived class must pass values to it using the base, base. Okay, so we're going to look at that. So here's just a example of a bank account. Has a number, type in a balance. Right? Here is your default constructor. Right? And always remember you have basically 3 different constructors in here, right? You have your default constructor, you have one with one parameter, right? Called overloaded, right? You're overloading it with one parameter. Here you're overloading it with 3 parameters. So always remember though, if none of this was here at all, just by default, right? Any class, if you only had these 3 here, by default, bank account, any class you create is always going to have this default constructor, even if it's not in here, right? It's just available in memory that every class always has a default constructor. But if you add additional constructors, right? All right, then you don't have access to the default constructor unless you explicitly put it in your code. It depends on what you want to do, right? Maybe you don't want someone using the default one, right? To use the default one, how you do is you generate, my bank account equals new bank account, right? Then you do that new bank account dot number dot type dot balance, right? You'd have to set all of those, right? Whereas the other way is you may have different ways you want to create a bank account. And so in this case, you're basically just doing it by number, right? The bank number. It's just so this is very common, right? In the real world situations, you open up a new bank account, maybe you don't even have a balance at the beginning, right? I mean, obviously, probably you're adding the money at the beginning, right? But when the company's setting things up, okay, we've got a new customer. We need to assign a bank account number, right? And so sometimes that's one of the processes they follow is they first just create basically an account based on the new ID that's given to a customer, right? So So in this case, it's just creating a number, right? Or creating a bank account based on a number. And here you're basically creating a bank account based on all available, fields here. Okay, but this is showing here. So back to this. Actually, probably a good way for me to show this is I got this split screen. Let me just go down here and kind of show this like this, maybe. Kind of did that the wrong way, but okay, we're good though. Okay, so here's bank account that we are just talking about, and here's the checking account, right? And so checking account has an additional field here, right? Overdraft limit. Now calls the parameterless base constructor, right? So when you do this, like this checking account dot base, right? This is calling the base constructor. This is calling this, okay? And then you're just saying your base type equals checking, right? Is that the right one? I thought that looked, okay, no, that's all right. All right, so, but it's calling the base type dot checking, right? Then here, this one here calls the base number one, right? So by you doing base here, you're actually calling this constructor and setting this on here. And so sometimes you kind of wonder why you want to do things like this. So in a way, you can have different kinds of accounts, right? You can have a checking account, a savings account, an IRA account, all these different accounts. And if you set things up in an object-oriented way, right, there's a lot of different benefits in that. And one thing from like a coding perspective you can look at is, a lot of times when we've done things, you like say, well, if you'd have to do if this account is this, then do all these things. Then you'd have another block. If this account is this type, a savings account, do all of these different things. But when you do things in an object-oriented way, you can kind of get away from all those if-else statements, right? It adds a lot more simplicity, and plus you're locking things down that you kind of got to follow the rules to create things, which are actually, really good, right? Instead of, because sometimes when you write your code, you just kind of put anything in there a lot of times. But, if you're following, object-oriented type concepts, right? And you're building things in the right way, giving things access that they should have access to, and then preventing them to have access to other things they shouldn't have access to, right? So because like part of like setting up a bank account, you might have social security number, some private information, right? You don't want to make that public, right? That needs to be private within some class, but not accessible to other ones, right? So just kind of trying to make a point there. Okay, so this one is basically calling, this one here is calling the one with the one argument, right? And then this one here calls the base one passing all three, right? But you always do this by doing the colon dot base, right? So you're basically setting it on here, okay? And, I know that's a little bit confusing. And, as we progress, you'll understand that more and more, okay? All right. So let's look at this. So when you call the new checking, so I'm just trying to get things in order here. So when you call the new checking account, passing in a value, right? Here's what happens. Order of execution, checking account int number is matched, right? Before the body runs, the colon base number calls the bank account int number, so it calls this constructor on the parent, right? The parent constructor body runs first, sets the number, then the child constructor body runs and sets the type of checking, right? Yeah, so that's important to kind of look at there. I'm kind of bouncing back and forth. I apologize. But the fact is, you're kind of setting up your bank account, right, by the base, but then you're actually adding to it because the default one, the default one didn't have anything at all, right? So here you're basically adding checking to it, right? And then actually then this one here, right, is just your one parameter where you're passing in a number, probably your bank account number, right? And then so you're passing in the number, right? So you're basically setting the number on this one. By doing this, you're setting the number. Then in addition, you're setting another field. You're setting your type field within this itself. Okay, so you're doing more than just that, right? So at this point, once you do this, right, you're going to have both the number, you'll have both the number and the type at this point. After you set this, you have both the number and the point. All right. Um, all right. Using the base to access the members. Let me go back to our. Let me just close one. Okay. We did that. Okay. Using base to access parent members. The base keyword refers to the parent class. Use it to access public and protected members. Always remember that, very important. Of the parent from within a derived class. Virtual methods and overriding. Okay. A virtual method is a method in the base class that derived classes are allowed to replace with their own version. So the base class marks the method with virtual, and a derived class uses override to provide its own implementation. Okay. So we have a shape class, right? It's defined to calculate area using virtual. Okay, so when you see the word virtual, you have to, remember what that means. So that means, hey, that means I can overwrite that, right? I can override that. So you can see in each one of these, it has an override. So it's overriding it for a circle and it's overriding it for a rectangle. Let me run over here to. Now this is something that the students who were already in the HTML course with me know a little bit about because we use this a little bit. We use this W3 Schools for that. So it's a w3schools.com. Now, there's some things, I just, as a caveat here, they do pretty good. They've actually come a long ways. There was a point in time where a lot of things were wrong at W3 Schools, and there was a lot of complaining and stuff like that. But within time, they've actually updated things. But always remember, this isn't kind of the ultimate source for, there's a lot of things you can learn in here besides just C#. They have, this is just a C#. You've got HTML, JavaScript, Python, Java. They have lots of different things you can learn from here, right? And they have examples and so forth. But, remember that this is not like the ultimate source for things. Obviously, for C#, it's going to be the Windows.net documentation is really the ultimate source. And sometimes they're using some things that might be a little bit older, right? In some of their examples. So just wanted to point that out. Okay, so we're looking at this inheritance one here. And I kind of want to show you. Let's see, which one did we have here? I was looking for a certain one here. Yeah, I want to do this animal one. So here, okay, it's got 3 different classes. You got an animal one, which is your base parent class, right? You've got a method called animal sound that just says, hey, the animal makes a sound, okay? Here you've got a class called pig that derives from animal, right? And then it's overriding this animal sound, right? Or it's adding this animal sound, and it's actually, you notice it doesn't have the override here, right? But this one says, the pig says wee wee, and then here's one for dog, which is a derived class of animal, okay? And this one also has an animal sound method. The dog says bow wow, okay? So let's go ahead and, all right. So this will basically be the output. And so for some of you who've already used this, you're going to you're used to kind of playing around with this. But, you can make changes to this as well, right? So this is just another tool for you to use for trying some things out. You can do the same thing within Visual Studio as well, right? But sometimes, with your window form stuff, sometimes it's nice to have something outside of that. You can just do some things kind of quickly, and and it's available for that. So if I basically run this, right? So, so I'm creating an animal, right? An animal object of type animal, right? And then I'm creating a pig, and I'm using the base class name animal, right? Base class, my pig, but I am creating a new pig. Okay. Here I'm using so this is this is actually part of object-oriented programming to do it this way, right? So I have an animal of my dog, which is a new dog. Okay. So this is all allowed, right? And so then you can do my animal dot animal sound, my pig dot animal sound, etc. Right? This stuff keeps popping up. Let me close that. So, but you did notice we did kind of some different. We had methods, animal sound, created differently for pig and for dog, right? But if you run this, what it's going to do, and it's kind of already did run it. It's going to just run. Sometimes it's slow. The animal makes a sound. It's running this one, right? And why is it running this one? Well, it's because we didn't really set this up correctly to have it run its own method. Okay, so let's go back here. All right. And this is a little bit of the concept of polymorphism. Okay. So we did that. So here is another example. Let me get rid of this one. Same stuff. The only thing that's different is we added the keyword virtual on the animal, right? And then on pig and dog, we use override. Okay. Everything else is the same. The only thing that's different is the virtual on the animal and the override on the dog and the pig. And then when we run this, it's going to do this, but we'll just go ahead and run it anyhow. But you can always change things in here as well, right? The animal makes a sound, the pig says wee wee, but you can also come in here and change this code, right? This should actually throw an error because of the override there, I would think. I'm not sure it does. Yeah, because it's trying to override something, but it don't have access because the only way it can override it is it has to be virtual, right? So, but this is always something you can play with a little bit. You can add some things. You can add some lines of code and rerun it. I have a bad habit of hitting Control S to save things just out of habit. and you don't want to do that here. So this just runs within, its little area here. But it's just a kind of nice little tool. You can come in here and play around with some things. Look at some of these different examples. All right. But like the important thing now is in here that since you've went ahead and used the virtual keyword, the override keywords, now even though it's an animal type, right? Right? It can run the different methods of pig and dog, right? Now there's a lot of benefit in setting up your code this way, okay? And and like I said, is well, here. Let me give you an example. Let's just say, the animal stuff isn't necessarily always a good thing, but let's just say you've got employees, okay, and you've got you got employee class, and you've got maybe like an hourly employee and a salaried employee, two different classes that derive. Okay, an hourly employee would be the derived class of employee, and have a salaried employee that derives from employee, okay? But an hourly employee is going to get based on, if it worked 40 hours, 45 hours, where a salaried employee is going to get paid basically their salary. If they work some extra hours or whatever, they're always going to just get paid their salary, right? But the way you calculate that obviously is going to be different, right? And that's how it kind of works. The same thing here for animal sound. For calculating, the pay would be relevant for the employee ones, right? But what you can kind of do here, instead of, like I said, you don't have to necessarily use an if statement to figure out, hey, is this an hourly employee or this is a salaried employee, right? You just get everything set up, and then you just say, calculate pay, right? And it's going to know based on how you have things set up is going to calculate it for an hourly employee or a salaried employee, or you could have an independent contractor employee. So you can have this all set up, and you just say calculate pay, right? You don't have to have all these if statements and else statements. It's just much nicer. There's a lot of other added benefits that we'll discuss later on as well. But just kind of wanted to kind of give you a real world example instead of, just some animal stuff. That, there's some other examples that it's very important to be trying to use object-oriented programming as much as possible. Okay. So like I said, you can come in here, shows you different things here. We've already done some enums. I probably should have shown you this before, but, you can try out anything you want. Try it yourself, and like I said, you can come in here and just update the code and run it. Right? There might be some things broke. I don't know. I don't go through all of these all the time, but just another tool to use to do some things quickly if you want to try some things out. And like I said, you can always change what you need to change. All right. Okay, so the override must match the base method signature correctly. Yeah. Good point on that. So if it's in your base class, it's got to match this exactly like this, right? If you changing it to an int or whatever, it's got to match it completely, right? Same return type, same method, same parameter types. Okay, same return type, right? So your return type here is a double, right? So if it's a double, if it's an int, it's got to be the same. Same method name, it's got to be exactly calculate area, and the same number of parameters, right? So in this case, no parameters. So if you change the parameter types, you're creating a new method, which is called overloading, right? So important difference between overriding and overloading, right? In this case, we're overriding methods, right? Overloading methods is when you add other parameters. Okay, so you could be having calculate area being a width and a height, and then calculating area to be something different, right? So if you have different parameters, then you're not overloading. You're over, you're overloading, not overriding. Sorry. Okay, polymorphism is the power of inheritance. So polymorphism means many forms, right? It's what happens when you store a derived class object in a base class variable. And that's what when we just looked at that animal example within W3 schools, that's exactly what we were doing, right? So C# automatically calls the most derived version of that method based on the actual type of the object, not the type of the variable. Okay? So in this example with the shapes, right? Shape, my shape, variable type is shape, but the actual object is a circle, right? Type shape. So it's important to kind of be able to, say, understand this from, knowing, okay, what's my type? My type is shape, right? My type is shape. The actual object is a circle, okay? So which calculate area runs? In this case, the circle version, okay? The circle version will be called. So even though the variable my shape is declared as type shape, the actual object is a circle. So C# calls the circle calculate area, not the shape calc area, right? This is called polymorphism. Okay. Polymorphism with arrays. The most common use of polymorphism is storing mixed derived objects in a base type array, then looping through and calling the same method on each. Each object represents its own behavior. So here you've got an array of shapes, right? And you're initializing it with 3, right? And then you've got shape 1, 2, and 3. First one's a circle, second one's a rectangle, and third one's a circle, right? Now you're looping through all your shapes. Each call uses the actual types override, okay? But like I said earlier, you have to make sure that your base class has that method defined, has that keyword virtual in it, and then each of your derived classes, when it overrides that, has the override keyword, right? And so this is basically going to call the right one, right? And like I said earlier, I mentioned a couple times already. So instead of, before we'd say, well, if this is, when we just did things, before we were doing objects in classes, but, when we had things, we'd have to check something. If it's this, then do that. You don't have to do this. Just calculate area, right? It's going to figure out which one to calculate, right? Multi-level polymorphism. Here, actually, before I do that, I just want to see if I can get away with copying all this in here into W3 schools. Just, because sometimes even if you're doing something else in that example, it doesn't really matter what you're doing, I don't think. And I know I've kind of done this before, but maybe I won't do I don't think it matters. But just kind of wanted to say, hey, maybe, I don't think we can do that there because I don't have the class. Oh. I don't know why it's not. This has this thing set up a little differently. All right, never mind on that. I think you still get away with small little examples will work. Yeah, but this one's got things set up differently. Sorry. All right, I regress. All right, multi-level polymorphism. When multiple classes in a chain each override the same method, C# always calls a version from the actual most derived type of the object, not the variable type and not the middle levels class. So let's look at that. So in this case, vehicle defines, so you got a vehicle with your virtual, calculate speed. You have a motor vehicle, and then you have an automobile, all right? So motor vehicle equals a new automobile, okay? So this is the, right? This one is the most derived, right? And then you do car calculate max speed. And this is going to call the automobiles version because the object is an automobile. Yeah, okay. The golden rule, the actual object type determines which override runs, not the variable type. If the variable is a motor vehicle, but the object is an automobile, you get the automobiles method. Okay. Yeah. And we already looked at that. Casting between types. So because a derived class is a base class, you can assign a derived object to the base type variable automatically. Going the other direction requires an explicit cast. Okay, so let's look at this a little bit. Implicit upcasting. Okay. So sometimes you have to kind of tell, the compiler, hey, this is what we're trying to do here. All right. So you can always assign a more specific type to a more general type, right? So in our case, a more specific type is your derived classes, right? And if you've got, 2 or 3 levels, the one at the bottom, the last derived class, right, can inherit from the one above that all the way up until the top base class, right? So you can always assign a more specific type, right, to a more general type without any special syntax. This is safe because a dog is always an animal. Okay? So here you go in dog, my dog equals a new dog. Animal A equals my dog, right? This is safe. Okay? So always remember, you can always assign a more specific type to a more general type. Okay, but if you're going from like a base type to a derived type, requires what's called an explicit cast because it might fail at runtime. Okay, not every animal is a dog. Right, kind of makes sense, right? Not any animal is a dog. So here, animal equals a new dog, right? That's all valid. Dog D, but here you have to, if you're wanting to go to a dog, right? Dog equals, so has to have an explicit cast. Works, right? Because A is a dog. Animal, like that's what's bad about the A's and the B's and the C's. A is a dog, right? It works because A is a dog. Obviously, this makes sense here. If you create a new cat object of type animal, right? Then you cannot cast that to a dog, right? So that kind of makes sense. But you do have to, so here you're kind of going from a type, your type is an animal, and to go from something that's more general to something more specific, okay? You have to tell it that because basically you can lose some things along the way, right? If something, and the same thing we've kind of did casting. We looked at casting a little bit when we were doing like doubles and integers and stuff. Sometimes you had to cast something to a different type, right? And sometimes when you do that, you lose things, right? So like a double, you can have decimal places with a double. An integer, you can't have decimal places, but you can take a double, right? you can create a new integer. You can have an integer variable that equals a double, but by default, it's going to complain about that because you have to cast it to an integer, saying, okay, and you're basically saying, I'm okay, I understand, I'm going to be losing some precision here, right? Because an integer is only going to be a 1, a 2, or a 3, right? Whereas maybe like your double was 3.1. So you kind of lost that. So kind of some of the same concepts. Obviously, that's primitives, right? Integers and doubles. Whereas here we're kind of talking about objects, so it's a little bit different there, right? But some things are kind of make a sense and kind of there's similarities there, right? So a way to do safe casting, because you want to be careful, because like when you do this kind of stuff, this is kind of like a runtime error, right? So a runtime error, happens. Your compiler could compile some things, but then when it runs, no, it's not happy, right? It's going to blow up. You really care a lot more about runtime errors. Obviously, compile times errors, that's something programmers figure out when they're building something, they're creating things, right? But a runtime error, you can build your code, everything's fine. Maybe you're doing something like this in some specific block of your code, but everything, you didn't even test that block of code. Then all of a sudden it goes into production, and all of a sudden one of the users tries to do something that calls a block of code that has the scenario, right? And then all of a sudden it blows up in production, right? So safe casting, you can do safe casting using pattern matching with is. So the safest way to downcast is with the is keyword, which checks the type and cast it in one step. If the check fails, the code inside the if block simply doesn't execute, right? So here you've got you created a new dog object of type animal, right? And then you're just doing if A is dog. So if A is a dog, basically, right? Then you can just go ahead and do what you want to do, right? You're basically checking it if it's a type, right? Checks the type and cast it in one step, right? So, I was talking about getting rid of if statements, but, sometimes you do have to, sometimes there's a benefit, right? So in this case, it's a good reason to use an if statement, right? And if it's not a dog, boom, it's not even going to work, right? It's just going to skip over this. It's not going to blow up though, right? All right. Type checking with type of, okay? So another way, the type of operator and the get type method can also be used to check get type. So it returns a type object that you can compare using type of. So type of returns a type object. Type of gets a type from the class name. So in this case, a.getType, does that equal type of dog? So exact type match does not match derived types of dog. Is usually preferred. It also catches the derived types. So two different ways to do it. Probably the easier, right, way. All right. Accepting any object. Since every class inherits from object, a method that accepts an object parameter can accept any object of any type. So the toString object works on any object. Any object that you create, you can run toString on it, right? We've already done it, even if we didn't realize. A lot of the things within the forum, a lot of those methods and stuff we've called things, and we just kind of probably maybe didn't realize it. It was, oh well, we just it's part of the C# programming language. Yeah, well, it's probably because actually a lot of these things actually inherit, right? You're inheriting these methods from base classes, right? And so system object is the ultimate base class, right? Do want to show you an example here just to kind of show you about toString a little bit here. So let me pull up this. Okay, so here's an animal. And it has a breed and stuff like that. So basically, you're just, it has two classes. Here's your base class, right? Dog is the derived class of animal, and it adds a new property called breed, right? So it's going to have both. So dog will have what? It's going to have a name, an age, and a breed now, right? And also what we're doing here is we're basically overriding this toString method, all right? Because actually this form actually is using a list box, right? And list box automatically call this method. They automatically call this method to get the display text, okay? But we're overriding this, right? This is not being overwritten from, this is being overwritten from what? So if I kind of actually just right click on this, and some of this stuff can kind of look a little confusing here, but don't get too hung up on that. We're going to go to base, right? So what is base going to be? Base is going to be what? Our object, right? Well, it's a little different how this does that, but basically here's the toString method, right? It's virtual, right? What do we know about virtual? That means you can override it, right? That's just how they've kind of changed things throughout time. But, it is basically system object here, right? How they kind of construct these things are a little different. So, you're kind of expecting certain things, right? But don't get too hung up on that. And we did talk about some other things as well. Remember, we were talking about like the equals method, right? That's an important one that we'll learn. Spend some time on that here in the future. So basically, an equals method, I'm kind of regressing here a bit. I was kind of just changing subject. But since we're here, this equals method, you take two objects and say, hey, are they equal to each other? Okay, right? But by default, so this one is also a virtual, right? So it can be overwritten. This is a static one. But basically, what I was and I kind of mentioned this already. So by default, if you do an equal, so if you created, like I said, let's say you created two dog objects, and both dog objects had all the same data in it. You try to compare those two equal. Use an equals method on those, to compare the two. They're not going to be equal because they're their own distinct objects, right? But what you can do is you can actually, in your dog object, you could override, okay? You could override the equals method so that it checks all of your data, right? It'll check all your data. I shouldn't say check, it'll compare. You can set it up to compare all your data. And if that matches everything, you can say, yes, these are equal. Even though, in memory, yes, they're their own unique objects, right? But from your perspective, right, you just care, are these values all the same, right? And so you can override the equals method to check all the values. When you run equals method on that, it's going to use the one you overrode, and it can compare those and say, yes, this is equal. Okay. But let me get back to what I really want to kind of show you here. So here, this toString method, you're doing an override on this, right? Printing out this, and then like it says on the list boxes automatically call this method, okay? Let me run this. Hopefully this is going to run. Okay, so I'm going to just click show dogs, and there was basically the toString method that was in there, right? Oh, yeah. Sorry, got confused. Has the age there. Okay, yep, that is the right one. Rex, Labrador, age, yes. So there, it printed that out, right? But what if we just get rid of this? And I'm just kind of making a point here. That's all I'm trying to do here, make a point about this. So now I'm going to run this. And what this is going to print out, I think it's changed over time just how they've done things. But now it's not going to print out anything we have here, but it's still going to call the toString method. But what it's going to do, it's going to call this toString method that is here, right? And this is it's just going to call the default toString method, right? Let me bring my thing back up here. Now, look, it's just printing out dog things. I've had a lot more experience with Java's similar to C#, but you know, back in the day, and maybe Java's different here in recent times, but what it would actually show is it would show a distinct number because it would actually show the memory, the memory value, kind of like the hex code of the object, right? The hash code of the object. It would print that out, which would be distinct. But it's just showing you it's basically two distinct objects. This is like we were talking about before. This is basically the references, right? This is just saying this is dog object 1 and this is dog object 2, right? All right. So, but it's still calling the toString method. It's just calling it from the base class, which is the system object class. Okay. Let me put this back the way it was. I'm in the wrong one. All right. Accepting any object. This is what we're just looking at. Since every class inherits from object, a method that accepts an object. Parameters can accept any object of any type. Oh, yeah, it's just showing you're using just this default object, right? You're just saying, hey, this is an object. Let's just do a toString on this object. So it doesn't matter what you pass in here. You can pass anything in here. So we could pass our dog object in here. We could pass a shape a shape object, a circle in here, a rectangle. It wouldn't matter. We could pass anything in here because we're just passing in an object, basically a generic object, and we're just doing a toString. And since toString is a method that's inherited by all objects, by all derived classes, pretty much everything, almost everything is an object, right? So basically you're doing a toString on it, and so it'll work on all these, no problems at all. That's all this is saying. Okay, abstract and sealed classes. Abstract classes, I know we talked about this a little bit, but an abstract class is designed to be a base class only. It cannot be instantiated directly. You must create a derived class from it. So abstract classes can contain both regular methods with code and abstract methods without code. Okay? So here you're defining this as an abstract class. All right? And you've got a property here. But here you've got an abstract method, no body, right? So the important thing is whenever you create an abstract method, you're always going to have a semicolon at the end. You're not going to have open and closed curly braces. Okay? So this is your abstract method, and then here you're just creating a regular method, right? Okay, shape equals, okay, yep. So you cannot instantiate a abstract class. So if you try to do this, this is going to throw an error. Cannot instantiate an abstract class, right? But you can use it as a type, right? You can use it as a type, right? And then create and have a new circle, just kind of like we did with animal and dog, etc., right? But one thing it doesn't show in here, is it going to show it here in a minute? I don't know. If not, we'll go through it again in the future. But one thing is, if you do this, you have to make sure that you provide what it's kind of called. The concept is called providing a. You need to provide an implementation of this. So you'll have to create the same method, right? So whatever. Oh well, this is color abstract class color. Yeah. Circle. Okay, I'm sorry. So basically, what you're going to have to do in your circle object, right? Your circle object, you'll have to create this method, right? And you'll have to provide the implementation. What are you doing in this method? Are you setting variables? Are you doing some logic? What are you doing, right? In this case, you're calculating area. So you'll have to provide your own calculate area anytime that you would derive, right, from shape. Anytime you decide to derive from shape, you're going to have to provide your own calculate area method. This you don't have to. It's going to be inherited. You could use it, but you don't have to override it or anything, right? You don't have to create your own implementation, but for this one you do. It's you're kind of creating this contract. You're saying, well, if you use my abstract class, you need to provide this method. Sealed class is the opposite of abstract. Okay, it cannot be inherited. Okay, so an abstract class is all about inheritance. The whole purpose. You can't instantiate it. If you can't instantiate a class, it's no good unless unless your only other options are for an abstract class. If you can't instantiate it, is to inherit it. Right. Otherwise, it can't be used for anything. A sealed class is the opposite of abstract. It cannot be inherited. Right. Sealing a class prevents other developers from extending it, right? So you might have something that, and this is kind of a security thing, just kind of like even like we were talking about protected and private, right? You want to control access to things. Kind of the same thing here. You don't I don't want somebody, I don't want anybody who's using my stuff, right? So maybe we haven't talked about how that's possible. Maybe from your perspective, you're thinking, well, I can just change it. But, sometimes you're using a library or something, right? You're using something where you can't just change it, right? You could rewrite all the code yourself, but you ain't going to, it could be part of a library that's pretty much constructed where you can't change it yourself, right? And if you want to use this library, you're going to have to realize that you cannot do certain things, right? You're going to have to abide by how that code was created, right? So if you use sealed on one, right, it can't be inherited, right? It prevents, developers from extending it. So here's kind of a review of this. Class type, a regular class, it can be instantiated and it can be inherited. Purpose, just general purpose class. An abstract class cannot be instantiated, right? Its whole purpose is to be a base class, kind of a base template class, to be inherited, right? Can it be inherited? Yes, required. Forces derived classes to implement abstract members, right? We already talked about that, abstract members. So anything that's labeled as abstract, you're going to have to provide your own implementation, right? A sealed class, can it be instantiated? Yes, you can instantiate a sealed class, but you cannot inherit it, So maybe like a math stuff, math things like, there's other ways to do this too, but so, just say some kind of a certain calculation that you don't want people changing it. This is the way you do this, like you figure out square root, you don't want to say, well, I'm going to devise, I'm going to change what square root really means. Well, no, you don't want to do that, right? So, but, maybe it's more, but, for C# and programming language, they always provide their own of those kinds of things. So that's a little different, but, you may have some other specialty type calculation that you want to provide, to anybody who uses your class, right? But you don't want to, you want to prevent inheritance so that they can't change it, right? Here, while reasons a sealed class to prevent others from inheriting it, to prevent others from changing how methods work through overriding. and improve efficiency. The runtime can optimize calls to sealed methods. Yeah. So yeah, we've never really kind of talked about that, So I think all different programming, languages have their ways. Systems have their ways of optimizing things when things run, and sometimes depends on how you developed it, how you created your code. That you can kind of make it in a way that the system, the IDEs, the code what's executed on a server to be optimized based on doing it a certain way. Overriding the toString, kind of already talked about that. ToString is defined as a virtual method in object. You can override it in any class to control what string representation your object produced. I think we looked at that, have a pretty good handle on that by now. We looked at that example exactly. Okay. When you add an object to a list box, yep, like we were talking about, by default, a list box automatically calls a toString method. Obviously, if you override it, then it's going to use your overwritten one. If you didn't override it, it's going to use as we've seen that, if you didn't override it, it's going to use the one from system object, right? So, quick review here. A system object is the ultimate base class of all C# classes. Provides toString equals, get hash code, get type, and more. Okay. Inherited syntax. Class derived. So the name of your class, and when you do colon, the base class. So the colon not extends or inherits. Okay. I don't like how that says that. Colon extends or inherits. Okay. So basically, derived class, colon, base class, right? Multiple levels. A class can be both a base class and a derived class simultaneously. Right? We had multiple levels where we had a vehicle, and then we had a motorized vehicle, right? Inherited from the vehicle, and then we had like a motorcycle inherited from the motorized vehicle, right? So that would be multiple levels, right? Where the motorized vehicle was a derived class of the vehicle, but it was the base class for motorcycle, right? Public, accessible from anywhere, we know that. Protected, accessible from the class itself and the derived classes, not from external code. Okay, private, accessible only from the class itself, not derived classes. And then, like I said, the idea of least privilege, we talk about that, and it's important, very important concept to understand within programming and access control. And it's based both on programs and users alike, right? You only want to give you want to give the least amount of access necessary to do the job, right? You don't want to give any more. So in your code, kind of the same applies as a user who has access to a system. You only give them a user access to things that they need access to. And the same thing in your code. You don't want to give access to anything it don't need access to. It's easy just to make everything public, right? Well, you don't have to worry about anything. Make everything public. But that's not good practice, right? Okay. Virtual marks a base class method as overridable by the derived class. Once you mark it virtual, once you see that word virtual, yes, I can override this, right? But you have to use the override keyword, right? Remember, we looked at that very first example in W3 schools, the animal and the dog, dog, cats, whatever, and the animal where we didn't use the virtual keyword or the override keyword, so it always called that parent one, right? Once we use the virtual keyword and the override keyword, then it called the correct method, right? Based on the object type. Abstract class cannot be instantiated, must be inherited. Abstract method, no body. Derived classes must override it. A sealed class cannot be inherited, prevents extension. Base keyword refers to the parent class. And then we also see where we call base dot method. We use the base dot, right, to call the method of the base class, right? Constructor chaining, right, passes values to the parent constructor. We looked at that, where we can actually pass different parameters, right, based on the available constructors of the base class. Polymorphism, the actual object type determines which override runs, not the variable type, right? So you have the variable type is on the left-hand side. When we had animal, we called it, animal one equals dog. And the one on the left-hand side of that, right, is going to be your variable type, right? On the right side is your object type. The object type always determines which override runs. Implicit upcast, right? Always safe. Animal equals new dog. Always safe. No cast needed. You don't have to explicitly cast. It's implicitly cast. It's not a problem. Okay. Now we got explicit downcast. Requires when going from a base to a derived, right? So, okay. Is keyword. Yeah. So yeah, well, real quick on this, just to kind of review. So basically, we can use this as an example. So this is animal, and you're um, trying to cast that to a dog. Okay, so that's called an explicit downcast, and you have to do it this way for that to work. Otherwise, you'll get a runtime. Your compiler probably won't catch it, and you'll get a runtime exception. Like I said, like when it's out in production, especially when you have, sometimes in that, that's what's an interesting part of actually programming. Sometimes, well, very important things of testing, right? When we're saying testing, a lot of times we do things manually for testing, but in the real world, you have kind of like test cases that run. It's like automated testing, right? Loops through everything, test everything out, right? That's why it's very important to test, because you could have something in some block of code, and unless you have the certain conditions to get that block of code, you don't know it's going to break, right? Until that scenario happens. There's the is keyword, and that's basically using pattern matching, and that automatically will actually go ahead and cast it and everything else. If it is a dog, boom, it'll cast it to the dog, right? Kind of we did this a little bit when we were doing a little bit of that type, checking types as well, right? Same kind of concept a little bit back when we were doing doubles and stuff like that. But A is a dog, right? If A is a dog, it'll go ahead and assign it to D, and then you can do what you want. All right, get type returns a type object with info about the object's actual type. Type of class name gets the type object for a class name. You use it to compare with get type. Obviously, is probably the simplest and probably the preferred way. Object parameter, we looked at that. The method accepting an object can accept any type of at all. That's where we had that toString where we used the object keyword, right? Used the object in that parameter. It was a type object. You can pass any kind of object in there. And whenever you're passing an object in there, if we were doing a toString, you're going to always be able to do that toString on everything, because toString is it's inherited from the system object, right? So that object, you could pass anything in that. You can always run any of those methods of system object, and they're going to work without you having to do anything with them. Just some common mistakes. So yeah, especially in Java days, Java is very similar to C Sharp. Java, you always use extends and things like extends. So you would use dog extends animal, but C Sharp use the colon, right? not extends, inherits. So, because some of these are ways, especially when you start using different programming languages. And, in this program, all of you as students are going to learn different programming languages, right? We can't learn them all, but you're going to learn some different things. And, well, sometimes it's different between different ones, right? And so, different, and sometimes when you start, you kind of forget what you're doing. You're especially when you're switching between programming languages sometimes, and you kind of try to use something that's in a different programming language, and well, no, that's not going to work, right? It's just kind of a common, I guess, just a common mistake that it's easy to make, right? Calling private base members from a derived class, yep, you can't do that. So if you want so if you know you're going to need, so basically, like I kind of said earlier about least privilege, so obviously by default make it private. But if you know that your derived classes need it, make it protected, right? If you know that I need to let this available to everyone, then you make it public, right? But by default, you from your perspective, you should think from, okay, I only give access if needed, right? So I'm going to make it private. Well, I need my derived classes to have it, so I'm going to make it protected. And then, like I said, obviously, if you need available to everyone, then you make it public. New shape. It's just showing you a mistake. You cannot use a new with an abstract. This is with shape being an abstract one. Can't do it. You can't instantiate an abstract class. Okay. Class, child, sealed, parent. So, yeah. So anytime you have a sealed class, you cannot inherit that, right? You will get a compile error on that one. Overriding with different parameter types. Right? Overriding with different parameter types. Yeah. So like we mentioned, it's really, this is another concept, really important to make sure you have your head wrapped around the difference between overriding and overriding and overloading, right? Overriding, you have to have the same name, the same return type, same parameters. Pretty much everything has to be exactly the same, except you can, within your curly braces, you can add different functionality, right? But the signature, right? That's called the signature. That's your return type and the name and all that. That's your signature, right? The signature has to be the same when overriding, right? For overloading, that's when you change your different parameters you're sending in, right? You'll have all of the other. You can have everything else the same, right? You can have the same return type, the same name, but when you start changing your parameters, right, you're overloading, right? Like we looked at overloading of different constructors, right? Okay, override signature must exactly match the base method. Forgetting the override keyword, yes. Yep, so if your purpose is to override the base class, your base class method, then obviously it always has to have virtual in the base class, and you have to use the override keyword. If not, it won't work. Think a variable type determines which method runs. Okay, yeah, and we already talked about that. Yeah, so basically it doesn't matter. On the left-hand side is your variable type, right? On your right-hand side is your object type. And so basically through the concept of polymorphism, it's always going to run, it's going to run the method based on your object type and not your variable type. And since I've talked about all these probably multiple times, I'm not going to go through all of these. We've kind of went through all of these multiple times already. So, okay. So that's it for chapter 14, or guide 14. So, all right. So next we'll go ahead and take a look at 15. All right, now we're going to go through pretty much interfaces. Let's see. Let me try to figure out how much of this is actually interfaces, and just going through some generic ones, obviously. All right. Okay, what is an interface? So an interface defines a contract. It's a set of methods, properties, and other members that a class promises to implement. So you don't inherit a interface, right? So it's done a little differently. Okay, so we'll take a look at that. Um, so think of it of a kind of as a checklist. If your class says I implement this interface, then it guarantees it has every member that the iPlayable requires, right? So everything that it defines in there, you have to provide. You have to provide implementation for those things. Okay. So an interface says what a class must do, but not how to do it, right? It says you must do this, 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 and this, but you provide the implementation on what those things do, right? So basically a method, kind of like the abstract thing a little bit, right? But you in an interface isn't to be inherited, and usually there's the relationship's different, right? So a lot of times when we talked about the base class, you know, not being an abstract class or not an abstract non-abstract class, but we were looking at it from a parent kind of child relationship where we looked at a vehicle, was the parent, and then you had motorized vehicle, and then underneath the motorized vehicle you had like a motorcycle, right? So you had an inheritance thing. Same with like animal, an animal being the base class, the parent class, and then a dog, right? There's a inheritance model there, right? There's it follows down, kind of a parent-child type relationship, right? But for an interface, you may just want to implement some certain functionality kind of thing, right? Kind of can look at it like that. If I want to implement this playable thing, right? This iPlayable, I don't know exactly how it's defining this. Basically, it's a thing for playing something. You play, you pause, you stop, right? iPlayable. So, and it's defined as an interface, right? It says an interface, but we haven't gotten there. But for that, so it's say something kind of a function, something you want to use, right? And so it's doesn't really it's not an inherited thing. You just implement it so you can use it, kind of thing, right? So in a way, it could be something that's not really related to maybe your base class or that. Obviously, you can have methods within a base class that you inherit, and you could use it for certain functionality. But sometimes you have things that this isn't really relevant to the inheritance model, so to speak, right? That's just some outside functionality you want to do, so you can use interfaces for that, right? But the important thing is, remember, an interface is a contract. Okay, it says what you must do. Okay, a class can implement multiple interfaces, unlike inheritance, which is limited to one base class. And I need to check this, and maybe I better just check this right now. Some things changed, and this might be referencing older versions. Let me check something, because I know that multiple inheritance is usually has been usually not something you can do, but let me check. I thought something kind of changed, and let me check there. All right, yeah, I just want to check. Yeah, yeah, and I should have known better. Yeah, you can't do multiple. I know you couldn't do it before. You couldn't do multiple inheritance. Base class, it only can have one base class, right? And that's always been the case. But some things have kind of changed with kind of in interfaces a little bit. We'll touch upon them when we get to that point. But okay, sorry. So the important thing is remember that, you can only extend from one base class, right? But so there might be some functionality you want to use that's outside the base class. It's a good use of using interfaces, right? And you can implement multiple interfaces, right? List them one, two, three, four, right? Interface inheritance. An interface can inherit other interfaces, okay? Combining their requirements into one. And I think that was the biggest thing I was kind of thinking about is the fact that you can interfaces can inherit from other interfaces, and I think that kind of changed at a certain point in time where you couldn't do that. But I think that now one interface can inherit from another interface, so you can have some inheritance as far as interfaces are concerned, but not from your classes, right? You cannot create an object from an interface directly. You can only create objects from classes that implement it. Okay. Yeah. So you don't instantiate an interface, right? You cannot create an object from an interface, right? Naming conventions. Interface name is C# always start with the capital I, right? So I clonable, I comparable, I playable. This makes them instantly recognizable. Okay. Declaring an interface. An interface declares method signatures, properties, and other methods, but traditionally does not provide any code for them. The members have no access modifier. They're implicitly public, right? So you don't have to say it's public. It's just when you use interfaces, by default, implicitly, they're public, right? Method signatures, no body, just a semicolon, right? And then also, well, yep. So no body on these either, right? Not that they're always necessary, but it's just showing you don't need a body, right? You don't have to say it's a protected, private, public. By default, it's always public. These are the method signatures. So this is basically saying if you want to use my iPlayable interface, then you need to provide these methods, right? You have to provide an implementation of all these methods. Interface properties use gets and sets with just a semicolon. No curly braces, no return statements, no value assignments. The implementing class provides actual code. So implementation of interface, a class implements an interface by listing it after a colon, just like inheritance, and then providing code for every member the interface requires. So here you just do colon I playable, and that's why you need to use the I first. So just to make sure that you're understanding that, hey, this is not a derived class, right? You're not using inheritance here, right? You're implementing an interface. So you kind of do it in the same way as what you're used to for a base class, but that's why you always want to have an I on your interface so that you look at it right away and say, oh, yep, I'm implementing an interface here, right? So you must implement every member from the interface, right? So had a title, had a duration, where you're stating that they're public, right? Here you've got you're overriding. You have to create an implementation for all of those methods of play, pause, stop, right? You do whatever you want in here, right? Depending on what your class wants to do, right? But you have to provide these, and that's what it's all about. By you implementing this interface, you're saying you're creating a contract with this interface that I will provide all of this. Okay. Inheriting a base class and implementing interfaces. Okay. A class can inherit from a base class and implement interfaces at the same time. The rule is base class first. Very important, base class first, then interfaces, all separated by commas. Okay. So it figures it out, right? It's going to figure it out, but you just got to make sure you put your base class first. And then after that, it's going to know, oh, yep, this is an interface. This is an interface. This is an interface, right? And then and just remember, you only can have one base class, but you can have multiple interfaces. Order matters when mixing, right? Interfaces and abstract classes. So interfaces and abstract classes both define contracts, but they have important differences. And we already kind of talked about, when we talked about abstract class, we're talking about kind of a contract, right, as well, right? Instance variables and fields. They can't have them, right? Obviously they can't have them. You can't instantiate an interface. Whenever you can't instantiate an interface, you cannot have instance variables, right? An abstract class can have them. That was something that's kind of changed with the abstract classes, is having instance variables. But all right, method implementation, default methods, C#8+. Yeah. So interfaces just have the basic, definition, but it doesn't provide the abstract. It doesn't provide all the implementation, right? And then abstract class, you can have regular methods and you can have your abstract methods. You can have both, right? Static members, static fields and methods are allowed. Static fields and methods are allowed in both. Multiple inheritance, a class can implement many interfaces, but a class can only inherit one abstract class. Constructors cannot have constructors. An abstract class can have constructor. You can't instantiate it, though. Okay, you cannot instantiate neither one. So, very common mistake. Someone, suppose an abstract class, trying to instantiate an abstract class. The critical difference, the most important distinction between interfaces. Interfaces cannot have instance variables like private string name. Even in later versions, they can have static fields and default method implementation, but no per object data storage. Object classes cannot have instance variables. They're there just for you. It's basically just that contract that you have to implement. It's basically what it's saying. I'm going to provide a default. The interfaces can provide default implementations for some or all of their members. A class that implements the interface doesn't need to implement members that have defaults, right? So here's an example where this interface has a default behavior, right? So then if you go ahead and implement this interface, the iPlayable interface, since it already has a default method, you don't have to provide one. You can, but you don't have to. You still cannot add, okay, using interfaces as types. One of the most powerful feature of interfaces that you can use them as variable types and parameter types. Any object that implements the interface can be assigned to a variable of that interface type or passed to a method that accepts that interface. So kind of interesting, right? So you got this podcast and audiobook that you've created. Here's a podcast class, right? You can actually assign that to a variable of iPlayable. Obviously cannot instantiate. We've mentioned that multiple times. Interface type parameters. When a method accepts a interface as a parameter, it can accept any object that implements that interface. So here, accepts any object that implements iPlayable. And we'll call the specific class's play method. Yep. So you're passing in iPlayable, but you're actually calling what? Calling the class's play method, right? You're calling the one that you defined on your class. Can pass any class that implements iPlayable. All right. Key role. The method that accepts an interface type can accept any object that implements the interface, not just any object, and not objects that happen to have methods with the same name, but don't implement the interface. I know a lot of this is confusing, and especially, I think with the inheritance stuff, a little easier. The interfaces kind of make things be a little more confusing there. So don't worry about it. Just kind of really just hang on to all those basics of interfaces. Understand that you can't instantiate an interface, and when do you use an interface? You're not using it to as from an inheritance standpoint, right? Things like that, and go from there, because it does take a little bit, of time to get used to the interfaces. So the .NET framework also defines several interfaces that you'll encounter, and you can implement these. So besides, you can create your own interfaces. We were looking at iPlayable. That's an interface that you've basically was created, right, for that example. But .NET has its own, right? It's called iClonable interface. Has a single method called clone, which returns an object type. You implement it to create a copy of your object. So you can actually create object copies, right? And so there's a iClonable, right? And then you can just implement your iClonable, and that you provide a functionality. This is just showing you didn't create this interface. This already exists, right? And it has this clone method, which you already know that if you implement an interface, you have to provide a concrete implementation of all methods, right? So you have to provide a default, concrete implementation, and you are doing that right here, right? And so you are creating a clone here. Using clone, you must cast back since it returns an object. Okay. Shallow copy versus deep copy. When your object contains reference type properties, like another object, you have a choice. What's called a shallow copy and a deep copy. A shallow copy, the clone and the original share the same inner objects. References are copied. Okay. When to use a shallow copy? When sharing the inner object is acceptable, or when all properties are value types. A deep copy is the clone gets its own separate copies of inner objects. Okay? When the clone must be fully independent of the original. So sometimes situations where you do this in the real world is, say you have a very complex application that's taking in a bunch of data, and you can start out like with this base copy of something, and then and instead of updating the thing, you can actually create a copy of it, and then you can keep updating that copy until you've got to a certain point, and then you can actually use that copy to overwrite your original. That's probably not a good example. I'll come up with a better example later. But, basically you can do where you have two separate copies of something, okay? And you can actually take and update your copy with data, right? And then use that later on. So that's one example where you want to, and that's where you want to have a fully independent one of the original. Okay, if you want to keep that original one because you may want to roll back to that default one, right? It's where something like you're doing something very complex, you're putting a bunch of fields on there, maybe pages and pages of, something really complex. You're adding a lot of, maybe tax return stuff. So you create a clone of, your base where you're at, and you start adding to something, right? And then if, I just need to roll back then to everything and start over, you can roll back to the original, right? So just an idea on that one. Okay. Just remember, shallow copy is a clone, and the original share the same inner object. References are copied, so they share the inner objects. So it's when you've got some, just think of a kind of a complex type object where you've got a bunch of inner stuff as well, where you don't actually, you're just copying. It's called a shallow copy. You're just copying the original, but you're referencing some of the stuff, right? Sometimes that's good enough. But if you want something that's completely independent, you need to do a deep copy, right? So that's probably the one thing if you want to think about. Remember a deep copy is going to give you a completely independent copy, okay? This decision is yours when implementing iClonable. For a class that has object properties, you decide whether your clone shares the same inner objects, shallow object, or gets independent copies deep. Neither approach is universally correct. iComparable. So that's just showing you, this is for sorting objects. So we'll learn a little bit about this later. I don't want to go into specifics, but you could do a compare where you can be reading, let's say, through a big set of data, and you compare them. And you just you're going through all these and compare them, and use what's called a comparable. Okay, so you're doing defines a compare to. So you're comparing one to another. So in this case, you're comparing other.name, right, to this dot name. This, okay? So this dot name, okay, that is your instance one, your instance variable. This always, remember, whenever you see this, remember you're talking about this instance, this specific instance. You could have objects where you have 10 different instances, right? You can have 10 different objects, right? Each one's its own instance. So this is saying this instance, this specific instance. So you're comparing the name of this instance to this one that you're passing in, okay? And that's going to could return a negative number, a zero, or a positive. And this is used very much into sorting objects. We'll look at this later, okay? IEnumerable is a class that implements IEnumerable, can be used for each statements. This is a primary reason to implement this interface. It makes your custom collection iterable, okay? All right. So we will get into, I know that these can be very difficult to grasp. We'll get into this more. Remember the purpose of each interface, iClonable, making copies of objects, right? You either have a shallow copy where the inner ones are references, the inner objects are references, or you can have a deep copy, right? And that's that's a completely different object, right? Independent object. iComparable for sorting objects, okay? And then compare to accepts a specific type. And IEnumerable is helps with for each loops on your class. Okay. Generics. So generics lets you write classes and interfaces that work with any type. So you can pass in different types. You don't have to state what kind of type. We're always used to have, so far, everything's got to be a certain type, right? So generics lets you write classes and interface that work with any type, with the specific type provided when the class is used. The type placeholder is traditionally called T. You'll see that, right? Generic classes. A generic class declares a type parameter in angle brackets. When you create an object from the class, you specify the actual type to use, right? So basically here, declaring a generic class, and have you got basically type array. You're just saying, usually you're used to creating a string, maybe like a string array, right? So this is making it generic that you could have a different types of an array, right? Some other kind of object array, right? An array list, a string array, right? Different arrays, right? So here you've got a public shelf. So you have basically an instance thing here, right? That can can be a different type, an integer. Well, this is an integer, but here's your type. This is your array, right? So this is going to be a number, right? 0, 1, 2, 3, whatever, right? But you don't even know what this is. Is this a string or what? Is this a string? What kind of an array that is this? An array of objects? It could have a different thing, right? So what you're doing is you're making a generic type. Instantiating a generic class. When you create an object from a generic class, you provide the actual type in angle brackets on both sides of the statement. So here you're stating that, specify the type in the angle brackets, right? So here you're stating, hey, yep, this is a string, all right? This one is an int, right? This one's an int, this one's a type recipe, right? And then that add functionality. So that add, like right here, right, it used the generic type, right? So whenever you call add, right, you have to have it set up so that it knows what type it is, and you do that, right? You do that by establishing the type at the beginning, right? So that when you call add, right, then, bookshelf, you'll know bookshelf is string, right? You'll know bookshelf in this case is an int, and in this case is a recipe, right? So that when you call this add, which is a generic type, since that you've already stated here what kind it is, then you're good to go, okay? Common syntax mistakes, make sure that type appears in angle brackets on both the variable declaration and constructor call. You need to make sure you have it on both sides. All right, generic interfaces. Just like classes, interfaces can be generic as well. You declare a type parameter in the angle brackets after the interface name. So right there. Okay, implementing a generic interface with a specific type. So as you notice in here, when you go ahead and implement it, you are stating what the type is at when you if you don't include this, you're going to get an error. You're going to get an error because you've already established this as a generic type. So you have to provide what it's going to be from your whatever class you're deciding to use for implementing this interface. So obviously, if you have this is a recipe book, you have something else, right? Another kind of a book, right? Then you need to provide a type before you do that. Otherwise, you're going to get an error, right? Pattern to remember when implementing iComparable for your own class, replace T with your class name. So like showing recipe here, this makes compare to accept a recipe parameter instead of an object. So what it's telling you, yeah, so it's basically telling you for the comparable, remember, so when you do the comparable to compare objects, right? That was for sorting, right? So you can pass in different objects of recipes. You have 20 different recipes. You're doing sorting them. Maybe you're sorting them by name or whatever. So using the compare to, you need to make sure that you provide the type, right? So in this case, recipe. So by default, it's going to be object. You know, just a just generic object. You have to state what kind. It could be you have to the certain type of object. Polymorphism with interfaces. Interfaces enable polymorphism just like interfaces do. Inheritance does. When you call a method through an interface variable, the actual object implementation runs. So let's see, polymorphism. Let's just go to here. Each object, which is its own play, runs. Okay, so here you've got a podcast and a video clip, right? Both implementing iPlayable. So they're implementing the iPlayable play. And then here you've got an interface typed array where, you know, and this is a really good use of just in general, you know, the idea of objects, and we were talking about that. That, you know, you can create an array of iPlayables here, right? iPlayables, and you can put in a podcast, you can put a video clip, different kinds. You know, we were always used to creating arrays kind of the same type and stuff like that. Whereas, you know, you're actually just creating, you can create an iPlayable queue, and then you can have whatever implemented your iPlayable, you can have different objects, right? All within it. So polymorphism, each object's own play runs. So in this case, when you call play on whatever one, you know, either you got a podcast or a video clip, it's going to call the correct one, right? Calling an interface method directly on an object. If you have a variable of a concrete class type, not the interface type, calling the method works directly. It calls that class implementation of the interface method. Okay, I was just showing you that. No, you know, no interface variables needed. So, all right, so let's go through, and, you know, please, I know this is a lot, especially when you start getting into these interfaces, can become very confusing. You know, I think some of that other stuff, you know, even though, you know, it takes some work to get, you know, the inheritance stuff, you know, not quite as bad. You know, when you start really talking about interfaces and stuff and generics really throw it. Interfaces by themselves, you say, okay, I can understand they're a contract. I implement an interface. I don't, it's not a base class. It's an interface. I implement it. You know, things like that. You know, not too hard to grasp. You can find. You know, obviously, when you start talking about really when generics start coming in, and you know, it can start getting a little more difficult to grasp. So don't feel bad. You know, we'll learn more about this as we continue on. Okay. But quick reference: an interface is a contract that defines members a class must implement. Right. So all the different members that are stated in there, and they're always going to end in a semicolon. Right. No, you can provide other ones, but The one, you need to make sure that all the ones that end in a semicolon in your interface, when you implement it, your class needs to provide a concrete implementation of those. Naming convention, interfaces start with an I. Okay. Please make sure you do that. That way you can look, especially when you're implementing those interfaces from that class, because you just use that colon, and so you want to know just by looking at it, hey, this is a base class or this is an interface, right? So if you start with an I on it, you always know that's an interface, right? So it's probably a bad idea to name your classes with an I starting at the beginning, huh? Well, actually, you name it with both letters being uppercase like that, an I and the second one as well. So, you can still start with an I on a base class. I shouldn't say that. But, it's still, you might miss it a little bit. But here you have the first two. You have uppercase I and then the uppercase of your interface as well, right? Multiple interfaces. A class can implement many interfaces, comma separated. A base class for interface. The base class must always come first. Base class, then your interface. Interface property syntax, getters and setters, just semicolons, right? Cannot instantiate an interface. Try to do that, you'll get a compile time error. Interfaces can't have instances, variables. Oh yeah, you cannot have instance variables. Default methods. Interfaces can provide default implementation. Classes don't have to override them. So you always have to remember the ones you have to override are the ones that end in a semicolon, right? If a interface has a default implementation on one of its members, you do not have to override those. Interface inheritance. An interface can inherit other interfaces. Interfaces as a parameter accept any object that implements that interface. And then some ones that are available in .NET, and we'll learn to use some of these. iClonable, that's to create clones. Okay. And you have to decide if you want it to be a shallow or a deep copy, right? Remember, a deep copy is a completely independent object in itself, whereas a shallow copy, some of the internal parts of your, if you have a complex object, some of the internal stuff will just be references to it, okay? iComparable, and it's used to compare to, and this is used a lot for sorting, accepts a specific type parameter, okay? So it's, if you want to sort objects, the problem is the reason really for this iComparable and sorting is if you want to sort objects, you have to sort them on something, right? You have to, you have to give it some kind of idea of how to do that, right? So the iComparable is, it really helps. So once you do that, when you return something, it's going to be returned in a sorted order that you want it to be in. INumerable enables for each loops on your class. Generic class syntax. T, if you ever see the T, always remember that is going to be a generic. That's a generic type, right? That's a generic type, meaning it can pass in different things, right? You can pass in different things. Generic instantiation, remember, you must, whenever you do call something that's defined with a type, right, and you call it, right, you need to make sure that you have these defined on both sides, right? Generic interface, here, just angle basis with your T. Implementing generic interface. Recipe book. So yeah, when you implement your interface, okay, when you're using generics. Okay, this is when you're using those generics. You're going to have to replace this with the type, right? So it knows what type you're passing in. It's great when you're creating something that you say, you can create something that this will work with any type, right? This will work with any type. But then when you do that, you need to pass you need to pass in what kind of type it's going to be, right? Common things. We kind of went through all of these already. And the same here. Okay, so that's all I have. Please don't get hung up too much on the interfaces and the generics. Okay, we some of that interface stuff's not too bad, right? You can understand it. It's a contract, like I said before, and some of that's not too bad, right? But once we really start getting into the generics, it can kind of be a little more confusing there. But don't get too worried about that. We'll deal with that when the time comes. So that's all I have here for today. Please let me know if you have any questions. And tomorrow we will go ahead and go through the demos for chapter 14 and 15. And that will touch upon what's needed for the labs in that, especially when we get to interfaces. So that's all I have. Thank you and have a wonderful day.